Hi guys, today I'm going to present the basic concepts of geometry. Let's start with it. We start with the notation. As you can see here, points or vertices are labeled by capital letters. We say capital A, capital B. Lines or edges are labeled by a small case letter. As we can see, A small, B small, C small, the three edges and lines of the triangle. Also, an angle is often labeled using a small case letter or a letter of the Greek alphabet. Three-point notation is also often used. For example, the illustrated angle here is theta or PQR or angle PQR, as you can see on the picture. Okay, let's continue with the line terminology. As you can see here, line AB is the endless straight line passing through the points A and B. And line segment AB is the part of the straight line AB that connects A with B. Let's continue. As we can see here, concurrent lines are three or more lines that all pass through a common point. Collinear points are points which lie in a straight line, as you can see at the points A, B, C, and D. Perpendicular lines intersect at right angles. Parallel lines are lines which never intersect. Arrowheads indicate parallelism. A transversal is a line which crosses over two other lines. Let's get to types of angles. The first angle on the left is 360 degrees, which is one complete turn. The second one is a straight angle, which is 180 degrees, and it is a half turn. And after a quarter of a turn, we get the right angle, which is 90 degrees. Also, an acute angle has size between 0 and 90 degrees. An obtuse angle has size between 90 degrees and 180 degrees. And a reflex angle has size between 180 degrees and 360 degrees. Types of triangles. The first triangle is a scalene triangle. It has three sides of different lengths. Right-angled triangle. One angle is a right angle, which is 90 degrees. Isosceles triangle. Two sides are equal. An equilateral triangle. Three sides are equal. Pairs of angles. Two angles with sizes which add to 90 degrees are called complementary angles. For example, the angles with 30 degrees and 60 degrees. And two angles with sizes which add to 180 degrees are called supplementary angles. For example, 120 degrees plus 60 degrees. Two angles which have the same vertex and share a common arm are called adjacent angles. As we can see here, PAQ angle and QAR angle are adjacent angles. For intersecting lines, angles which are directly opposite each other are called vertically opposite angles, and they are always equal. Theorems and properties of angles. Angles at a point. If we add them, we get 360 degrees. That is, A plus B plus C equals 360. Adjacent angles on a straight line. They are supplementary. As we can see, A plus B gives 180. Adjacent angles in a right angle. As we can see, they are complementary. That is, A plus B equals 90. And vertically opposite angles. which are always equal. A equals B. Corresponding angles. When two parallel lines are cut by a third line, then angles in corresponding position are equal in size. As we can see, A equals B. Alternate angles. When two parallel lines are cut by a third line, then angles in alternate positions are equal in size. Co-interior angles, also called allied angles. When two parallel lines are cut by a third line, then co-interior angles are supplementary. The sum of the interior angles of a triangle is always 180 degrees. As we can see, A plus B plus C gives 180. The size of the exterior angle of a triangle is equal to the sum of the interior opposite angles. As we can see, C equals A plus B. And the sum of the interior angles of a quadrilateral is 360 degrees. That is, A plus B plus C plus D gives 360. Now, let's get to secondary elements of triangles. Here we can see a triangle ABC, and the line segment AD is the angle bisector for this triangle, which means that the angle A1 equals to the angle A2. The median of a triangle ABC. Here we can see the median, which is the line segment AM, which bisects the side BC. That is, BM equals MC. Height of a triangle. The line segment AH is perpendicular to the side BC. That means that the angle H is 90 degrees or a right angle. Perpendicular bisector. We can see that the line M is perpendicular to the side BC. And also BF equals FC. This is the end of our first presentation. The next one will come soon. Thanks for watching.